Section 8.2, graphing simple rational functions. So a rational function simply has the form of a fraction. So in other words, your numerator is going to be a polynomial. In other words, it contains an x, and your denominator is going to be a polynomial, or in other words, it contains an x. And since you can't divide by 0, obviously your denominator can't be 0. To begin with, you're going to see two types of equations, as you can see in your note packet. And we're going to do something first so they look the same. To begin with, this one that looks like it has two terms, we're going to combine it and write it as one fraction first. And then these two forms that we have at the top will be the same. And so to find a vertical asymptote for either one of them, once they have the same appearance, you're going to set the denominator equal to 0. You can't divide by 0, so this is basically going to be the y-coordinate, or a vertical line, that x can never be. In other words, the function will approach this line, but it will never actually touch it. And so that's going to be the form of a vertical line, x equals some number. For the horizontal asymptote, we're basically going to be looking at the ratio of the coefficients, in other words, the number part of the term, of the highest powered terms of the numerator and denominator. And in this section, our simple rational functions will all have a horizontal asymptote that will be found by looking at this ratio. The next section will get into some that will not be as simple to find. So let's start out by looking at some very basic rational functions. Let's look at the parent function for rational functions, y equals 1 over x. And they're going to lie in quadrants 1 and 3. And so if we look at this first one, if we're just pick some random points, not random points, pick some positive and negative points, it'll be fairly easy to graph. -3, -1, 0, 1, and 3. And you'll see since we can't divide by 0, we're going to get where it's not defined at 0. And so now let's take a look at y equals 6 over x. Again, let's pick those same values. When we plug in -3, we get -2. -1 will give us -6. Again, it's not defined at 0. 1's going to give us +6, and 3 will give us 2. And when we plot those, we can see that graph. And now let's look at where do you think that the graph of y equals 4 over x is going to fall in relation to 1 over x and 6 over x? My guess would be that it's going to fall between them, since 1 is between 4 and 6. So again, I'm going to pick some convenient numbers to pick. And when I plug those in, again, I'm going to get that 0 is undefined. And when I plot those, it does indeed fall between them. So for all three of these, if we were to set our denominator equal to 0, we would get a line x equals 0. That's going to be our vertical asymptote. And if we were to let y or x get really, really large, in other words, what is it approaching, we'll never actually have 0 as x gets huge, approaching infinity, but it will approach the horizontal line y equals 0. The domain and range for each of these. Remember, the domain is your x coordinates, so how far left do these graphs go? Well, they go from -infinity all the way up to 0. They don't include 0, so that's why it's a parenthesis. And then it picks up again from 0 all the way to +infinity. For the range, we're looking at the y. So in other words, how far down does it go? Again, -infinity, up to 0, not including 0, and then again from 0 on up to infinity. All right, let's look at one that's not quite as simple. So again, this is one that has two terms. So we're going to rewrite this. So 3 over x minus 4 plus 2, let's write that as a fraction over 1. And when we write two fractions as 1, we can multiply 3 times 1 and get 3, plus, since we're adding these two, and then multiply the other diagonal, 2 times x minus 4. And then we put that over and we multiply together the denominator. So x minus 4 times 1 is just x minus 4. Distributing that 2 on the numerator, 3 plus 2x minus 8 over x minus 4. And then combining the like terms, we get 2x minus 5 over x minus 4. And so now my vertical asymptote, if I set the denominator equal to 0, I'll get x equals 4. So that's my vertical asymptote. So I'm going to draw a dashed vertical line at x equals 4. For my horizontal asymptote, I'm going to look at the ratio of the coefficients of the highest powered term. Well, my highest powered term on the numerator is x, and the highest powered term on the denominator is x. So if I look at the ratio of that 2 over 1, I get y equals 2. And I'm going to draw that horizontal asymptote. My t-chart now is going to be dictated by my vertical asymptote. I need to figure out what it's doing on the left and right of that vertical asymptote. So I'm going to start with that in the middle, 4. And I'm going to pick 4 values to the left, 3, 2, 1, 0, and 4 values to the right, 5, 6, 7, and 8. You can either plug those into the original equation or this new one that we had after we combined it into one fraction. When I plug in 0, I get 1.25. Plugging in 1, and 2, and 3. Again, if I were to plug in 4, I would get 0 on the denominator. I can't divide by 0, and even your graphing calculator won't graph anything there. And then again, plugging in 5, 6, 7, and 8. Plugging those points in, plotting them, and then sketching the curve along those asymptotes, we get that that's what our curve looks like. And now thinking about my domain, again, my domain is my x, so how far left does it go? It goes off to negative infinity, and it goes all the way up until 4 this time, because that's my vertical asymptote where it's undefined. And then it continues on from 4 to positive infinity. My range, again, we're looking at how far down to up, so it goes from negative infinity, and this time it goes all the way up to 2, my horizontal asymptote, and then it continues from 2 to positive infinity. Now that we have done one of the examples, I'd like you to try to do this one on your own. Determine what the vertical asymptote and the horizontal asymptote would be, and graph them. And then again, based on your vertical asymptote is how you're going to determine your t-chart, and then plot those points and see if you can graph it. And we'll talk about this one in the beginning of class tomorrow. This one is similar to the other one we did, so again, the first thing I'd like you to try to do is write this as one fraction. So remember that you're going to write it as 1 over 1, and then you're going to multiply the 9 times 1 plus the 1 times x plus 5 all over the x plus 5 times 1, and get a single fraction and do it like the previous example. And now let's start setting up this one. So to become a member of the YMCA, you must pay a joiner's fee of $185 and a monthly fee of $30. Write a model that gives the average cost per month as a function of the number of months you've been a member. So the average cost, what does that mean? Well, our average cost is going to be the total cost divided by the number of months, and that would be the average monthly cost. So what goes into the total cost? Well, we've got our joiner's fee, and then we've got whatever we're going to pay every month. And again, we need to divide that by the number of months. So our joiner's fee is $185. We pay that just once, so we're not going to multiply it by anything. And then we pay $30 per month, but that's not just a one-time $30 fee. We need to pay that every single month, just the $30. And again, to get an average cost, the number of months, again, is divided by m. So I'd like you to do the rest of these, this B, C, and D, now that we've set up the model. You're going to need to use, if you want to use your graphing calculator, or you can graph it by hand if you don't have one. You're going to need to think about your window, so think about what your x is, since we don't have an x and a y in this problem, and what the smallest that could be, and what the largest it could be. And then think about what the y stands for, and again, what's the smallest that could be, and what's the largest it could be. And think about what we've learned in this section. Then I'd like you to also think about what the approximate horizontal asymptote is, and what exactly does that mean. And again, we will talk about this one in class as well at the beginning of the hour. So please make sure you come with any questions you might have, and try to do those problems that I didn't. That's how we'll be starting class, and we'll see you tomorrow.